Well, I figured it's about time for me to provide a description of the Skyhunter airplane. So, everybody builds them differently. So here's how I built mine. Propulsion is from a Himax Outrunner brushless motor. It's a HC316-1350, and it's driving a 9x6 propeller, 9 inches diameter, 6-inch pitch. And it's been a great motor. This motor and the ESC, which is a 54 amp ESC made by Castle Creations, was sold as a power package by Ready Made RC. I'm not sure they sell that or not still, but that's how it is propelled. By the way, the 54 amp ESC will overheat if you run it at too high of a current for too long a time without airflow. So to get the airflow to it, I just made a little air scoop, cut a hole in the side of the fuselage, and that solved that problem. The propulsion batteries are two 5 amp 3S batteries from Hobby King. So it's a total of 10 amp hours, 12 volts nominal for the propulsion batteries. They're connected in parallel. I also have a redundant battery on board, a little Nanotech 3S 370 milliamp hour battery. It provides redundant power to the video transmitter, the servos, the little flight computer, and the front camera. In the nose of the plane is the nose camera. It's permanently mounted 15 degrees below horizon, and it's a 1000 TV line camera sold about 9 years ago by Ready Made RC. I don't remember the part number. I'll look around. If I can find it, I'll put it at the end of the video. It's a good camera, but it's fixed in position. It's one of 2 cameras on the plane. It's the one I normally use to get from place to place. The second camera is a belly camera. It retracts and extends, also using the redundant battery, the small 370 milliamp hour battery, to power the retract extend mechanism. So it just extends into the airspace. It's got 150 degree pan on it, and it's got a tilt of 70 degrees. And that's the camera I normally use to view things when I get to a location. The video transmitter is a 1.3 gigahertz unit, nominally 800 milliwatt output, sold by Ready Made RC. They still sell them. I'm running it at 1258 megahertz. The antenna is a home-built half-wave dipole, which works pretty well, but it's not perfect. So I'll be improving that later on. And a little better view of the dipole. It's definitely not resonating exactly at 1.258 gigahertz. It's a little bit off, so I have to fix that. The long-range receiver is made by Immersion RC. I've got it mounted out on the end of the port wing. Unfortunately, it's not an S-bus receiver, so I had to run all the wires all the way back into the fuselage. The long-range receiver antennas are, of course, tuned for 433 megahertz. It's a diversity receiver, so there's a dipole antenna as well as a little whip antenna, and I let the receiver figure out which one is getting the better signal. The opposite wing also has a lead counterweight, just to counter the weight of the receiver and the wiring on the port wing. For what it's worth, this counterweight is 65 grams. In the center of the horizontal stabilizer, there's another counterweight. And even though there's the video transmitter mounted on the vertical stabilizer on the starboard side, I still needed extra weight on the tail because, unlike most Skyhunter builds, I don't have a GoPro camera at the nose of the aircraft. The camera up there at the nose isn't very heavy, and the 400 plus gram weight of the retractable camera is located right at the CG. So I need a little weight on the tail to get the CG right. Another change I made from stock is I mounted the elevator servo upside down with a control horn coming out the top of the horizontal stabilizer, just to keep damage from landing, just keep landing from damaging the control horn and the servo. So far it works great. Here you can see how I routed the elevator servo wiring out the tail boom and across the top of the horizontal stabilizer, and through the stabilizer, routed along the bottom all the way to the elevator servo. And that wiring coming out of the boom goes right to a plug, so I can unplug it from the remainder of the wiring run and remove the tail surfaces if I need to. The wiring for the video transmitter comes right out the bottom of the vertical stabilizer and goes into the boom. Again, there's more connectors so I can take the tail surfaces off without any problems. Also, I use a couple of heat sinks on the video transmitter to keep it from burning up when testing it and when the unit's just not moving through the air. I attached them to the video transmitter using thermoconductive epoxy. And like most people that build these things, I put some reinforcement between the vertical and horizontal stabilizers. Just a little piece of carbon fiber just to keep everything nice and steady. And the weight of the plane ready to fly is 2.9 kilograms. All right, so those are the details of how I built a Skyhunter for FPV. If you have any questions, I hope this is helpful to you. And if you have any questions, feel free to just let me know. Thanks.